Hi, and welcome to MSc. In this video, we're going to be looking at function notation. So function notation has the general form f bracket x bracket. We say f of x when we describe these. We would say that it has a general form of f of x. Now this is not multiplication in here. Not multiplication. And we're used sometimes when we see brackets that will imply that you multiply with what's out there on the outside of the bracket. That's not the case here. What this actually means is that there's a function that by default we often call f, but we don't need to call it f. We will sometimes choose letters that will describe the function itself. If it's a function of area, maybe I'd use capital A. If it's a function of height, I'd use h. Volume v. And so we can personalize it. And then the value of this function depends on the independent variable x. And again, it doesn't always have to be x, but that's our general placeholder. But if it was time, then we would use t, for example, instead. So we understand what a function is. And if you haven't watched my video on explaining functions, then you should go take a look at that video as well. But a function is a special relation that only has one output for every input. So the general form of a function is f of x, written in this manner here. This general notation of a function will replace the y equals that you might have used before. So in the olden days of before this video, you might have used notation like y equals 5x to be a line that has slope 5. Well, now what we'd write is we'd write f of x equals 5. And this has some features that allow us to do some interesting things with it. If I wanted to evaluate this line, which we know is a function because it passes the vertical line test, if I wanted to evaluate it when x was 2, you would sub in a 2 for x, it'd be 5 times 2, and you'd say, well, y is 10. And you'd say the answer is 10. And if you do that a bunch of times, that you're quite capable of doing that, you can create a table of values to do that. And that's fine. It's the exact same skill now, except when we write that out, what we'd say is we'd say f either at 2 or f of 2 is equal to, and then you'd sub the 2 in for the x. So we're replacing the x with 2, because now instead of it just being the general independent variable, we're now saying I want to know the dependent variable f when x is 2. And so we'd say f at 2 is equal to 10. And this has the benefit now of being able to see the dependent variable f, the function 10, and my independent variable of x being 2. So let's try another one. Let's try evaluating this function when x is negative 1. Well, what that means is I'm going to sub in to this equation here when x is 1. So I'm going to sub negative 1 in, rather, for x, and that's going to be negative 5. And so I'd say f at negative 1, my function at x equals negative 1 is negative 5. So it's just a format of writing that allows us to sub in the x value and carry that through, and then it has a memory at the end of which x value we actually substituted in. We don't multiply these, right? This is really the argument, it's what's going into the function itself. So at the end, especially if it's a multi-step process, I'll see at the end my independent input and my dependent output. Let's look at a couple of examples. So here's another example of a line, which we know is a function. And let's evaluate this when x equals 3. So the way we'd write this, just like before, we'd say f at 3 is equal to 2. And now instead of x, I'll put the 3 in, just like we would have if we were filling in a table of values, minus the 3 from the equation above. And we'd do BEDMAS, so this would be 6 minus 3, and we'd get the output that when x is 3, the function is also 3. And we could graph this on a grid by saying that this is my x-axis, and this axis, instead of calling it my y, I could call it my f at x axis. And I'd be able to graph this line that might look something like this. And this would be an x-intercept of, a y-intercept rather, of -3, and it would have a slope of 2, right? Because we know that the slope is 2 and the intercept is -3. And so what we found out is when x is 3, y is also 3. So we found that value up here somewhere. When x is 3, y is also 3. Let's try one more example with this one, and then we'll move over to the other example. So let's try now when x is 0, so f of 0 or f at 0. Well, all I do is sub in that 0 for my x value in my equation. 2 times 0 is 0, minus 3. This is -3. Well, I knew that already. That's my intercept point, right? And then at the end, I can say f at 0 is -3, and I can see my coordinates right there. My coordinates of that point are going to be 0, comma, -3. So this function notation allows us to a different manner of substituting in and tracking down what we've done all the way through. Otherwise, I'd be left, if I'd done as a y equals, which is still fine, you could still call it y if you wanted to. But if I had this and I substituted in for x, I would just get y equals -3. And I'd have to look back at my work to figure out what my input was. Here's another example of a parabola. And we know it's a parabola because it has a squared term and a non-squared term and then a constant term. I've used intentionally something different than f and x. So this is h of t, probably some type of height over time. Maybe it's a projectile or something like that, moving through the air perhaps. And we can evaluate this in exactly the same way we did before. I can figure out what is the height after a time of 5 seconds. And I do that by substituting in for t with 5. So we are solving here when t equals 5 is what we're actually substituting in, right? So I'll put 5 squared plus 8 times 5 minus 1. So every time I see the t, I replace it with 5 in my equation. This is now the function evaluated at t equals 5, so it doesn't change. This would be 3 times 25 plus 40 minus 1. And so this would be 75 plus 40 minus 1. And then we'll finish this off. So 75 plus 40 would be 115, minus 1 is 114. And that's how we substitute in. So try one here. Let's try a negative number. Let's try -2. And pause the video if you'd like and try substituting t equals -2 into this parabola and come up with the answer. So if you've had a chance to try that, that'd be great. We'll substitute that in. So we say h of 2 or h at 2 is equal to 3. And then instead of t squared, we'll put -2 squared plus 8 times -2 minus 1. And then we'll say 3 times 4, because -2 squared is positive 4, minus 16 minus 1. And this will be 12 minus 16 minus 1. And we'll get an answer. 12 minus 16 is -4, minus another 1 is -5. So that is a brief rundown on function notation. It is a different way of writing out our functions. Instead of being reliant only on saying y equals, we now have a variety of techniques and variables we can choose from, and at the end of the equation we have all the data right in front of us. When t was -2, our height is -5. I hope that this video has been helpful for you. If it has, please consider liking the video and subscribing to the channel. And as always, thank you very much for listening and watching.